Hi, this is Paul. I'm going to show you how to implement row-level security in a Power BI desktop project that will move up into the Power BI service. Now, the basic tenets and concepts of role-based, row-level security are the same, but there are some variations depending on whether you're using it with analysis services on-prem, analysis services in Azure, or you're just using a Power BI model with imported data that you've then published to the service. And then there are also some variations in the techniques you might use depending on the data that you're protecting and filtering based on users that log in. So what I'm going to show you here is we have a very simple project. Most of the data in this project has been imported from the Contoso DW database. So it's a sample database in SQL Server where we have things like customers and sales. And let's just jump over to the data model. So you can see that I have a sales table, I have a customer table, and we'll just forget about that table right now. I want to be able to let my sales reps only see the sales information for those customers that are in their territory that they tend to. Now I may want to have other users who would be able to see a superset of those customers. So I need some flexibility in the way that I map my users to my customers, but I don't want a user to be able to see any customers or any related data for that customer if there isn't an explicit mapping in this table. Now for our purposes, I've actually put our security mapping information into an Excel workbook. Let me just back up and talk about the kind of the conventional approaches. If I were doing this in an on-prem solution using analysis services, either multidimensional or tabular, this is probably the way that I would enter those users because that's what they look like when running on a desktop or through Active Directory. I'm going to see the domain as a prefix, /, and then the user's network name, which could be a first initial last name. It's however those users are configured. Now, when we deploy a Power BI solution up to the cloud-based Power BI service, we actually use what's called a UPN. And that UPN looks, it's how the user logged in, typically using an email address. They call it a UPN because we don't really treat it as an email address. If it happens to be an email address, then that's all well and good, but it's really just a string in this format. And so there you see a little bit of a dichotomy about how things work in the cloud and down on-prem. I've decided to simplify that quite a bit. This is just my technique, but what I'm doing is I'm just taking the name off of each of those different formatted name strings. We're just going to use the name. Now, I have to be able to strip the name off of whatever name format it's in. And I've actually done this right here in a measure called username short. So you can see that my username measure, all it does up here in the upper left-hand corner, all it does is it returns the results of the username function. I have another function that returns the value of the user principal name, which when used with analysis services through a gateway might be useful, where I can actually map my usernames to names that we recognize within our domain. I'll do another session on using the gateway with analysis services and where this would be useful. But this is my username short measure right there, if I can find it. There we go. And here you can see that I'm actually looking for a slash or looking for an @ sign. So here I use a variable to say, if there's a slash in there, search for it. That returns a character string value to let me know that you found it. And if it's in there, I want to know what the position is. Otherwise, return a 0 if it's in error. You do need to use this if error function, by the way, because if it doesn't find that value in there, it will return an error, and it's the if error and the 0 at the end that cause it to return 0 if the string isn't found. Same thing here with the at. I need to know where that is. And then in my return block, I'm going to say if slash position is greater than 0, in other words, there was a slash on the string, then go ahead and use that with a mid function to give me the name, everything after the slash. That'll just be my network name. And if that's not found, then go look for the at position. If that's greater than 0, then I know that that one was in there. And so give me everything to the left of that at without returning the at position. So that's just going to return my name. In my case, Paul. It could be P. Turley. It could be Bob or Robert or Mary. So that's an important measure for my purposes. Now, let's take a look at our report real quick. Right now, I have unfiltered data. So we might say that with all of these customers, we've got thousands of customers. These are just the quantity of orders for those customers. This might be sensitive information we don't want to show all of our sales reps. And so I have a set of records that I only want certain sales reps to be able to see. And so I've entered 4 records for Sherry. I'm just using the customer key right here. So for these 4 customer keys, Sherry should be able to see those records. And for these customer keys, Paul should be able to see those 3 records. All right, I've just got some testing information here so I can actually see those customers and see what security keys or usernames they were mapped to. And so we're going to go ahead and put this to the test. So I've got a simple report here. It's just a list of customers with their quantity. And then I've got some simple sales information. That's the quantity information by product. Now, I just wanted to point out that we have some unclean data in this model, which is not unusual. I have sales records with customer keys that don't match records in the customer table. So this is a referential problem. It's a data quality issue, but I have 109,000 sales records that don't match to a customer record. And those potentially could fall through the cracks and could show up for a user if I don't take steps to make sure that they don't get to see that data either. So the first thing I'm going to do to implement security is go to the Modeling tab. I've clicked the Create button. I've typed Customer Sales Rep. So that's just a name of a role. I can have as many roles as I want, but the filtering based on customers applies to customer sales reps. Now I'm going to go over to the customer table and I'm going to say I want to filter the customers that a particular set of users gets to see. Now we could just say customers are in the state of Washington. Assuming we have the full names of the states there, any users that are in this role would only see customers in the state of Washington. So that's a very simple filter that I could use where it's statically assigned, but we're going to do something a little more complex than that. We're going to say where the customer key value matches the customer key value from my security bridge table. So I've already imported that security bridge customer table, and I have an expression that I'm just going to paste here, and that looks like this. This is the conventional approach. You notice that I'm using the username function here. The username function is either going to return that domain or computer name / username or the user at domain.com or whatever their UPN is. And so rather than using username, I'm going to use my username short, and that's that measure I created that is going to reduce, shorty, that is going to reduce that string to a specific name to match up my security bridge table. So let's take a look at this logic really quick. The lookup function returns a value of a named column within a table. In this case, I'm saying go get the customer key value from the security bridge customer, where the customer key value equals the customer key value from this customer table. I don't have to prefix that with the table when it's in the context of the table that I'm filtering. All right, while you're at it, go pass in my username column from the security bridge customer table and see if it matches the results of my username short measure, which effectively is just the name that I've logged in as. All right, so we're going to go ahead and save that. And to test this, I'm going to actually publish this. So that will be up in the service here in just a few seconds. Publish that up into Paul's Playground app workspace. This is a very small model, and so we should get a link popping up here pretty quick. I'm going to follow that link. Now, before we can test this, we need to make sure that security is set up correctly. And that is performed on the data set. When you publish a PBIX file, it extracts a data set and a report. And so we're going to go to Paul's Playground. We're going to go to the data sets. You'll see the name of the file here. I'm going to click on the ellipsis, more options, and then choose security. So you can see that I need to add some users. So I'll add Paul. And since this is connected with my Office 365 subscription, it looks up my email address, as I can look up Sherry's as well. I'm going to add her. I'm going to add those two. We're going to save those settings, and we should be good to go. So since I'm logged in, I happen to be an administrator, so I'm able to see all of the data right now. But we want to use my login and see what would happen if it only applied the filtering for my login regardless of my admin status. So I'm going to click this ellipsis on the role. I'm going to say test as role, and we should see only the customers that I have access to. Okay, so that passed the test with one exception, and that exception is my data quality problem. Because the lookup value function, if it doesn't find a value, it's going to return a blank. And then I also have in my customer table, because that's where I'm getting this customer key that I'm matching up, well, that's a blank because it's an orphan. And so all of those blanks match up, and I get all of those sales records that have those orphan customer keys. So we could argue that this 109,000 and some record count might be a number that's meaningful because it represents all of those orphaned customers. We want to get rid of that. It's just dirty. The best way to get rid of that is to make sure that we don't have any orphan records, but we can't always ensure that that happens in the security world. So let's go back and just add a simple piece of code. We'll go back to manage roles so I can see that expression. And I'm just going to add this DAX expression that says, and the customer key in the customer table is not blank. All right, don't want to return any rows where the customer key is blank. Let's add that. Let's go ahead and redeploy, publish, do a save first. So everything should remain in place with the exception of the updated role logic. Let's go navigate to it again. There's our raw data. We'll go to the data set, security, and go ahead and test it as that role. And this time we don't see the orphan records. I see only the 3 customers that I have permission to see, and we have a secure model. And this will work with all non-admin users who view this data using any tool.